But we're going to continue the conversation, just chit chat a little bit, and then start the presentation in 5 minutes or so. This is going to show up eventually on YouTube, and you can always fast forward. My man, Philip Bogdanov, how you doing?
Good. How are you, Hart?
Good. Hi, Steve. I got your email. And Steve, and I'm not ignoring you. Well, let's talk soon. Philip, tell me what you've got going on in Australia,
Oh,
if you don't mind.
hello, can you hear me there? No? No.
Oh, hi, Steve. Yeah, well, you pushed mute again.
Sorry.
Yeah. We're going to start the presentation. If you're joining us live or via recording, we're going to start the pretation in,
Great.
5 minutes or less.
Cool. That sounds great. I'm trying to work and listen in at the same time, and if I have any thoughts, I'll chime in. And sounds great.
Steve, if you weren't multitasking, I'd be disappointed in you. I mean, we got important work to do here. It's about time you got your butt in gear.
You're right, but I have no option but to multitask. I got a house full of kids and plenty to do.
Yeah. Well, I thought you were doing it because you love the process of multitasking.
No.
Okay.
Yeah, no, I'd love to have time to scratch myself. It doesn't happen, unfortunately.
Right. Sometimes I scratch myself when I should be working, and that doesn't always go too well.
Actually, one thing I do love about these webinars and guys like yourself doing lots of the reading and research is I can sort of, while I'm not well read, I can be well listened. And, while you're working, you can listen to the great insights of yourself and others in this space. And it's very valuable. Thank you.
Well, it's, I heard you were very well read. So, anyway, I do the same thing. I listen
No,
to
that's
people's
not
content.
true.
Mhm. Yeah. So we've got David, Steve, and Philip from Australia. I'm just really
Great.
happy to be international here. Philip, can you hear me?
So, yeah, I'm in Tacoma Park outside of Washington, D.C. You may be
Oh, okay.
confused.
Yeah, I'm getting you confused with somebody else. Tacoma Park outside of Washington, D.C.
Yep,
So Maryland or Virginia?
Maryland,
Mhm. What county
sometimes
is
known
that?
as the People's Republic of Tacoma Park,
Well, I would expect nothing less.
or
Oh,
the Berkeley
it's
of the
not
Indian.
Montgomery County, is it? Did you say
Yeah, it
Maryland?
is.
Montgomery
Yeah,
County? Well,
County.
Montgomery County has some really good, you're doing really good work, I think, in landscaping, like, limiting the use of gas blowers and toxic pesticides and things like that. I mean,
Yep.
good stuff. Good stuff.
And we had some prescient people 40 years ago who used the transferable development rights scheme to protect 93,000 acres, about one third of the county, for agricultural purposes.
Cool.
Montgomery County Agricultural Reserve. It's nation's first and best.
Did you say 90,000 acres?
93,000. Yep.
93,000. That's big. I grew up working on a farm that was 5,000 acres, so that gave me some concept of what 1,000 acres looks like. So, and David, in Australia, people are still talking in terms of acres. In the English system, y'all call it the colonial system. We call it the English system. But I noticed that you talk in meters, but you talk in acres. So it seems like you're kind of mixed between the two measurement systems.
Well, you when you're talking acres, it's bigger, isn't it? If you're talking,
yeah,
in
more. There's
hectares,
more acres than hectares, right?
yeah.
Yeah, it's like there's less miles than kilometers.
we only changed over in about 1970. We had acres, we had feet, we had even pounds, shilling, and pence up till the late 60s.
Pounds, shilling, and pence. Wow.
Yeah. So we went metric.
Yeah.
In the late 60s, but a lot of old timers never changed.
My truck has a thermometer that's stuck on Celsius, and maybe I'm too lazy to figure out how to change it to Fahrenheit, or maybe I want the challenge. But I figured out, okay, 0 Celsius, it's like there's 30 degrees in between freezing and very hot. And that's how I kind of think of it. 0 is freezing, 30 is very hot. And so if it's halfway between, it's probably, 15 is probably 55 Fahrenheit, that kind of thing. So I'm kind of getting the hang of Celsius. Anyway, let's do this presentation. Let's do this. Okay, slideshow. I'm going to do a slideshow from the beginning. So we're going to talk about farming and climate. And let me do this so that, let me see. I need to share the screen. Okay.
And you want to remember to start recording if you wanted to do that.
Yeah, appreciate that.
Hi, Lucy.
Lucy's with us again. Lucy from Maine. So I'm going to share my screen. Here we go. So I think I've learned that no matter where this thing is, it's kind of out of the way on the recording. So let's talk about farming and climate. I'm going to try to push it out of the way a little bit more. Let's talk about farming and climate, how farming impacts our climate and what we can do about it. I personally think that farming is probably the single biggest impact on climate. As much as I hate to admit that, I would like to think that defense is a bigger impact, and it's a huge impact. Transportation is a huge impact, but I think farming is the biggest. And let's see how that works. Questions to be explored. How does farming impact our climate? How? What are we doing in our farming that has a ripple effect to the climate? And how does it work? We're going to talk a lot about carbon, water, and ecosystems. Those 3 interrelated, interconnected things. This presentation is about maybe 30 minutes, and I may or may not pause in the middle to have a discussion. We'll see how that goes. Let me see, what time is it? It's 7:09. So how does it work? What are the moving parts? So the moving parts include carbon, water, and ecosystem. And the things that we do in farming that have a big impact on those things include soil, like soil as a resource. How do we manage the soil? And also fertilizers and tillage. And there are other things like biocides, but we're just going to talk about fertilizers, tillage, and soil and see where that takes us. And what can we change to make this better? Well, we can attend to healthy soils. We can know how farming impacts carbon and change some of those things for the better. We can know how farming impacts water, change some of those things for the better. We can know how farming impacts ecosystems and change some of those things for the better. So here are the 2 parts of this particular presentation. Part 1, carbon, water, and ecosystems, those 3 interconnected moving parts. I even did a Venn diagram for this. I hope you'll be impressed with that. Part 2, soil, tillage, and fertilizers. Soil is a resource. Tillage is a tool or a method. Fertilizers are tools or methods. And we'll see how what we do to those things impacts soil, water, impacts carbon, water, and ecosystems. So let's get started. Part 1, carbon, water, and ecosystems. How does farming impact climate? Anything that impacts carbon or water or ecosystems impacts all 3. So if you impact carbon, you impact water and ecosystems. If you impact water, you impact carbon and ecosystems. If you impact ecosystems, you impact carbon and water. It's like Siamese twins. They're conjoined. You cannot affect one without affecting the other. And all this in turn impacts climate. Of course, today we hear only about carbon. Scientists may be talking about all kinds of things, but the popular imagination thinks it's all about carbon, baby, and it's all about what comes out of our tailpipes, which is very far from the truth. So we're talking about a virtue. This could be a virtuous cycle. So what's good for one, what's good for carbon or water or ecosystems is good for all three. What is bad for carbon or water or ecosystems is bad for all three, and we'll see how that works. But for example, ecosystems add carbon to the soil, or if we till, we remove the carbon from the soil eventually, and that impacts the ability to hold water, which in turn impacts ecosystems. They're all interconnected. And so here is a virtuous cycle. In the next 5 slides, we're going to talk about one virtuous cycle. And somebody wants in. Marion Cook from Pittsburgh is with us now. So water makes plants grow. As plants grow, they absorb carbon from the air. Marion, if you're just joining us, we're talking about how farming impacts climate by way of impacting carbon, water, and ecosystems. So water makes plants grow. We've known that since we were 3. You have to water the plants. We've known that, but what we haven't known is that as plants grow, they absorb carbon dioxide from the atmosphere, and that's not all. We're going to see that they take some of that carbon, about 1/3 of it, and inject it into the ground. And that's not only good for getting carbon out of the atmosphere, but it's very good for plants and ecosystems, and it's good for the ability of the soil to hold more water, and we need that. Item number 2, this is a 5-part virtuous cycle. As plants grow, they provide food, water, and shelter for animals, thus forming ecosystems. So an ecosystem is an interaction between plants, animals, fungi, microorganisms, sunlight, water, and minerals. And that's what an ecosystem is. But it starts kind of with plants and animals and quite often soil. And as plants grow, they form ecosystems. As ecosystems grow, all the plants and animals absorb carbon and water into their tissues. So we know that plants absorb carbon, but I've come to understand that, yes, you and I have a lot of carbon and water in us. By weight, we're mostly water and carbon-based organic molecules, including carbohydrates, fats, and proteins. And so animals are also storehouses for carbon and water. Number 4, as plants grow, they take carbon from the air and inject some of that carbon into the soil. It's sometimes called a liquid carbon pathway. About 1/3 of the carbon that a plant gets is injected into the soil, and that's where soil ecosystems come from, and they're very important. We can do our farming with soil ecosystems or with a complete disregard for soil ecosystems. It's a choice. One choice is very good, one choice is very bad. Number 5, carbon-rich soil has greater capacity to absorb water. There's about a 1-to-8 ratio here. 1 gram of carbon increases the soil's water holding capacity by about 8 grams, or 1 pound of carbon increases the soil's water holding capacity by 8 pounds, which is approximately a gallon. So pound of carbon, gallon of water. It's a massive increase, or what the United States Department of Agriculture says is that a 1% increase in soil carbon increases the ability of an acre to hold 22,000 gallons of water. That's huge. So carbon-rich soil has a greater capacity to hold water. The more carbon there is in the soil, the more water the soil can absorb. This causes plants and ecosystems to grow. So why are we talking about this? Because the climate conversation is all about carbon. You can't isolate any one thing and expect to do much with it. And it's really important that we talk in terms of interrelated systems. So these virtuous cycles are the key to understanding how farming impacts our climate. Now, that was part one. Now, part two. We're going to apply this understanding to soil, tillage, and fertilizers. So let's talk about who does what, meaning conventional agriculture versus regenerative agriculture. We call it conventional, but it's radical. Conventional has only been around for since about 1950. Actually, some of it has been around thousands of years. Tillage has been around thousands of years, but synthetic fertilizers have been used on a large scale only for about 70 years. So we're going to talk about compare and contrast conventional with regenerative. In the yellow here is healthy soil. Conventional farming versus regenerative farming hardly means no. So conventional farming is not concerned with healthy soil. Regenerative farming is concerned with healthy soil. Grow the soil and the soil grows the plants. Tillage, conventional farming, yes, yes, yes. All tillage all the time, baby. Lots and lots and lots of tillage in conventional farming, but in regenerative farming, there's some regenerative farmers do no tilling at all. Some do some. I mean, the Rodale Farms in New York tills about every third year. And so there's that. So it's not about being pure or perfect. It's just, but regenerative farming is little or no tillage, and for good reason, because we'll see that tillage tears up the soil. The third of the three items is synthetic fertilizers. Conventional farming does a lot of synthetic fertilizers. These fertilizers were just incidentally, not coincident. They were developed by the German war machine. It's the Haber-Bosch process. It's how do you get nitrogen out of the air, where the air is 78% nitrogen. How do you get nitrogen out of the air and put it into a chemical compound? That's the Haber-Bosch process that was developed in 1915, somewhere around in there, around right before World War I. And but regenerative farming doesn't use very many synthetic or hardly any, in fact, practically none. And we'll see why, because it's very destructive. Now, let's look at some of the details. This means I'm going to do some numbered lists here. And so healthy soil, what can we say about healthy soil? It contains carbon. Healthy soil contains carbon. In North America, the carbon content of the soil was between 6 and 8% before Europeans arrived. Now it's down to 1 to 2% in many places. That's a huge difference in soil carbon. Healthy soil, but we can get that back. We can take our carbon poor soils and store a lot of carbon in them if we choose to. So healthy soil also contains air. It's about 1/2 to 2/3 pockets of air. And that's important because the ecosystem needs air. Plus, when it rains, it absorbs water. So healthy soil contains water, number 3. Number 4, healthy soil contains an ecosystem, living things. Healthy soil contains living organisms. So backing up to the top here, tillage and synthetic fertilizers destroy the soil carbon. They destroy the ability, they destroy these air pockets that otherwise exist. They destroy the soil's ability to hold water. They destroy the ecosystem and the living organisms that are in it. It's a completely, tillage and synthetic fertilizers, just a completely different philosophy of farming, completely different understanding of what we ought to be doing to the soil and what we ought to be expecting of the soil. Tillage and synthetic fertilizer, what can we say about them collectively? Well, they destroy everything that makes the soil healthy and functional, including soil structure, Soil is structured like a sponge. It's easier to tear apart than a sponge, but as long as the soil structure is in place, it's very important for having air pockets and water pockets and a place where living organisms can do their work and feed off of one another, etc. And a place where the roots of the plants can have a home, can contribute to the ecosystem, and can get nutrients and water and minerals from the ecosystem. So tillage and synthetic fertilizers also destroy the soil carbon, and they destroy the soil ecosystem. Now, tillage, what does tillage do? So it tears up the soil, it kills living organisms, it destroys soil structure, it turns a sponge into powder. If the soil is a powder, it's not soil, it's dirt. The life has been taken out of it by whatever means, by compaction or by tillage or by synthetic fertilizers or by biocides, but bad soil is a powder, or maybe it's just pure clay, but it's not going to be what Walter Yenny calls a soil carbon sponge. And tillage makes soil incapable of holding water. It's important that soil be able to hold water, that you can reduce erosion, you can reduce runoff, you can reduce water pollution, you can have a reservoir of water to help grow plants. If the soil can hold water, then you have an extended period of time in between rain events that your plants can continue to do well. And this is how we mitigate the effects. This is how we can survive a drought. This is how we can even thrive in the middle of a drought, is by increasing the capacity of the soil to hold water and continue to water the plants even while there hasn't been rain for weeks and weeks and weeks. Walter Yenny says that you can extend the period of green growth from 10 days to 100 days just by having a soil carbon sponge that has the capacity to hold water in between rain events. So what do synthetic fertilizers do? They kill soil organisms. They stunt the plant's natural ability to recruit bacteria and fungi. So when you have healthy soil, the roots of the plant inject carbon into the soil. That carbon it's in the form of sugars. When the plant puts sugars into the soil, then these soil organisms, these bacteria, come and feed off of that sugar. And when they do that, they deliver nutrients to the plant. They set up an entire ecosystem where they're feeding off of one another and delivering nutrients to one another. The plants are interacting with the microorganisms, including your bacteria, but also, multicellular microorganisms like nematodes and things like that. All that only happens if the plant perceives a need for nitrogen and other nutrients. But let's say you put nitrogen fertilizer down, then the plant says, well, I've got all the nitrogen I need, so I don't need to inject carbon into the soil and set up this ecosystem. So that's bad news. The nitrogen fertilizers are like a drug. They work for a while, but they have side effects, just like if you and I take drugs. So number 3, synthetic fertilizers make the soil incapable of holding water for reason, it destroys the soil structure, and they cause erosion. Not just cause erosion, but when the synthetic fertilizers, when it rains, then you have dirt and chemicals going into the water supply. So, and it can make the water undrinkable. It can, even after like Iowa sometimes has problems. Iowa, a state in the US, about 10 hours from here, for those who are not oriented. I'm a pampered, sequestered, cloistered American. I have no idea, I know how warped we are, and I don't know what other people know. So pardon the, don't mean to insult anybody's intelligence. So The synthetic fertilizers cause erosion. Yeah, yes, in the state of Iowa and Des Moines, sometimes women, children and nursing mothers are not supposed to drink the water even after it's treated because of these darn nitrogen fertilizers that get into the water supply. It's horrendous. And we're doing this to grow what? Corn for animal feed, for concentrated animal feeding operations, and corn for ethanol. It's criminal what we're doing to our natural resources to grow stuff that is not needed. The synthetic fertilizers pollute the water. Yeah, been talking about that. So we're almost done here. Almost done, coming down the home stretch. So, but let's apply our knowledge. I probably can rifle through this in the interest of time because we've already talked about it. But, let's speculate as to how soil, tillage, and fertilizers impact carbon, water, and ecosystems. And so you have my handy dandy Venn diagram, carbon, water, and ecosystems. What does healthy soil do for carbon, water, and ecosystems? Well, healthy soil is an ecosystem. So it's an ecosystem that interacts with the plant roots, and it holds water. Healthy soil is able to hold water. Healthy soil, by definition, has a high carbon content, a medium to high carbon content that is a gift that keeps on giving. It's a resource that you can continue to draw on. And if you're a farmer and you want the value of your land to go up, you want to be increasing the carbon content in your soil. I'm just saying. So what does tillage do to carbon, water, and ecosystems? Well, tillage destroys the ecosystem, because to have an ecosystem, you need that soil structure like a sponge. It destroys the capacity of the soil to hold water. And tillage, what impact does tillage have on carbon? Well, the carbon is there partly because it's in the soil. It's stable carbon, like humates and glomalin are the two types of carbon that are stable, that can exist and continue for decades or centuries. But also some of the soil carbon resides in living things. And when you kill the habitat that these living things live in, then you've got decay and decomposition. And that's when the carbon turns from sugars into atmospheric CO2. And we've been doing that for thousands of years, and about half of the carbon in the atmosphere is from tillage, not from burning fossil fuels. And we can reverse that process by storing, we can reverse that process. The soils of the earth have a tremendous capacity to hold carbon. If we're concerned about carbon, we will reverse what we've been doing for thousands of years. Next item. What do synthetic fertilizers do to carbon, water, and ecosystems? Well, they kill the ecosystem. That has the same effect. You destroy the ability of the soil to hold water, and you make the carbon decompose into carbon dioxide, which we don't need. We need that stable soil carbon and the structure that it provides for the soil. So conclusions. Conclusion number one, farming dramatically impacts our climate by impacting carbon, water, and ecosystems. Conclusion number two, only by understanding these moving parts can we effectively advocate for change. And we also, Noam Chomsky uses this term that I like. He says intellectual self-defense. So he teaches like a ton of history. He's a tremendous history teacher. So once you learn history from Chomsky, it's like, hey, I know a lot of stuff I was never taught in school. So, and it's intellectual self-defense because you know BS when you hear it. You know something that is completely inconsistent with the clear understanding that you've come to understand. So when people say the most ridiculous things in the name of climate, and a lot of it is lies of omission. Not talking about agriculture, except every now and then you'll see an article but we're not giving agriculture anywhere close to the attention that it rightfully deserves because of commercial influence and because of just, not knowing what's the what. So we can effectively advocate for change if we understand these moving parts. Conclusion number 3, we need to rethink conventional practices like tillage and synthetic fertilizers whose negative impact far exceed their benefits. We can get our food from ecosystems, or we can get our food from extractive polluting processes. Currently, we get most of our food from extractive polluting processes, not from ecosystems. We need we need to practice biomimicry. We need for our farms to mimic or imitate what nature does. We can do that, and we can produce a lot more food if you include food that nature eats and wildlife. So conclusion number 4, farming can be natural and ecological, or it can be toxic and destructive. It's a choice. It's a choice. And the only reason we have the toxic and destructive form of agriculture, at least in the United States, is because it's subsidized. The fossil fuels are subsidized. If you didn't have cheap fossil fuels, you could never do this type of farming. It's subsidized through crop insurance, which is really, in the long run, bad for farmers. It's only good for about 20 agribusiness corporations, but they've bought Congress. So the system is rigged for the benefit of the agribusiness corporations and everybody else's expense. So that's why it's currently toxic and destructive. But we as consumers and farmers and citizens and advocates and communicators need to kind of orient as many farmers as possible over to a profitable regenerative system. And we can do that even if policy never changes. But if we did enough of that, policy would change. So this has been farming and climate, how farming impacts our climate and what we can do about it. And a recommended resource, Dirt to Soil by Gabe Brown. I know some of you guys in Australia have read Dirt to Soil by Gabe Brown. It's I'm an audiobook fiend, and Gabe does a great job of narrating his own audiobook. And also you can find Gabe Brown on YouTube. If you just Google Gabe Brown, probably one of the top YouTube videos is Treating the Farm as an Ecosystem. It's an excellent presentation. And if you have any further questions, this is written by me, Hart Hagen. Thank you very much for listening. And you can contact me at info@theclimatereport.net, or that's my phone number. And so I'm going to stop the share, and we're going to have a little conversation if y'all want to. So, hey, Maren, how you doing? So Maren kindly and graciously invited me to speak to her group in Pittsburgh. That was they call it salons. Maren, that is a really good program that y'all have. And Barbara Berman, very good friend of mine in Louisville. Steve Bonnewell, we talked. Thank you, Maren. Steve Bonnewell was here last week. We talked about some stuff. Philip in Maryland and Lucy in Maine, David Thompson in Australia.
So Hart, if I could just augment what you've done there, very, very nice overview and structuring of the information, I think, to give people the outlines of what we're talking about, the difference between conventional and regenerative agriculture. I'll just start by saying somewhere between 25 and 30% of the CO2 that's in the atmosphere currently that humans put there came through land use change, deforestation, and also plowing the prairies and oxidizing all what used to be, I think, 6 to 8 feet of organic matter is now down to about 18 inches in the, the central plains of the U.S. And you're right, we could reverse that. In fact, one of the very first talks at our Biodiversity Global Climate Conference in 2014 was by a professor at the University of Oregon who's a specialist in fossilized soils. And he showed how the fossil record reveals that with the coevolution of herbivores and grasses, huge, prodigious amounts of carbon were taken out of the atmosphere and put in the soil, and it actually cooled the planet globally significantly. The other piece that I think I learned a couple of months ago is that only about 1% of the energy in this, coming from the sun is used by plants in the process of photosynthesis. They're actually fairly inefficient in that chemical transformation of CO2 and water into sugars. But about 70% of the energy is used by the plant to move water to transpire, basically to suck water from the roots and through the trunk and the stems out through the leaves. And that actually takes that energy that otherwise would have, warmed bare ground, creating sensible heat, infrared heat coming from soils and rocks and whatever. And instead it turns it into water vapor. So the heat is latent in the water vapor. The water vapor rises to 10, 20, 30,000 feet and turns into clouds and eventually rain. And when that condensation happens, it's high enough off the ground that a portion of it, a significant amount, I don't know whether it's 10 or 15 or 25%, radiates to space. And then when the rain comes down again to the ground, usually downwind by 100, 500 miles, 1,000 miles, starts that process over, provided there are plants on the ground. So that small water cycle actually is, every time it goes around, is shedding heat to space. It's taking heat that otherwise would have warmed the surface of the earth and shedding it to space. And Michael Kravchuk has looked at historical records, and he's done this calculation for every continent. I only know the one for the US or North America. He says that through tillage agriculture, creating bare ground, compacted soil so that when it rains, that water runs off, through the loss of beaver, which created holding ponds all across the US. When the Pilgrims landed, about 10% of the US was underwater thanks to beaver ponds. And of course, all the paving that we've done, the urbanization, he says we now sluice away the equivalent of a Lake Erie every year off of North America that used to be held for years, many months at least, giving that water a chance to percolate into the ground and be part of those small water cycles.
Right.
And we are advocating for the rapid restoration of those bare grounds. The mantra should be, if you see a piece of bare ground, plant something green on it. And of course, there are many areas around the world where it will be difficult to do that because they're adjacent to deserts, or we've created virtual deserts through the loss of fertility in what humans used to farm, or we've irrigated to the point where the salinization keeps plants from growing. But I think we now know how to restore most of that, and we could very rapidly. Walter Jena says, as soon as you start planting green on bare ground, within 3 to 5 months, you should feel a cooling effect from having done that. And we have some studies. I have one right here. Let me just give you one factoid. Paper by Vic Stoy and a bunch of others looking at changing fallow cropping practices in Montana and some of the southern Canadian prairie provinces. They saw a cooling trend of 6 watts per meter squared in the summertime And just for comparison, greenhouse gases are responsible for a 2.5 watt per meter squared warming. So they more than countered the warming
Right.
from CO2 in the atmosphere by
Right.
changing basically what they did. Instead of letting the land be bare after the crop was harvested, they had a cover crop that covered it, and that helped reduce the regional temperatures.
Yeah, a couple of observations to echo that. One is that, you know, we in the climate conversation, we talk about greenhouse gases, but we forget that the greenhouse effect has multiple factors. Greenhouse gases are only one factor in the greenhouse effect. The other major effect is surface temperatures. We can change surface temperatures by what we have on the ground. So that's one thing. And then the other thing is, I forgot the other thing. That'll have to wait.
Well, water vapor is the primary greenhouse gas above
Right.
even CO2 and methane.
Mm-hmm.
It's just that it's so darn complicated to model that they gave up on trying to model it.
Yeah, and they decided decades ago that we're not going to look at water. We're not going to look at water as a greenhouse gas, and we're not going to look at the cooling effects of water, because the assumption was that water is so pervasive that humans couldn't possibly have an effect on it. Well, that's obviously the opposite of the truth and the opposite of common sense. We have a dramatic effect on water, not least of all by what we can broadly call land use. Well, whatever we do to the land, it's going to affect water. Farming, urban development, landscaping, forestry or deforestation, it all affects water. And so.
And as David knows, fire.
Right. So I heard that when Australia was having the forest fires, that Jeff Lawton's place did not the forest fires were all around, and Jeff Lawton's place was impervious to it because it was moist. You know, he had a water table, the plants contained moisture. The fire just did not affect his farm the way it did everything around it. Subject to verification, but I heard that from one source.
Yeah, I've heard that too.
Who else has some thoughts for us?
Hello. Can you hear me there? Steve here.
Yeah.
Yeah. This last couple of weeks, I've been enjoying watching some YouTube clips of Super Biotic Pump. Have you guys ever heard of that? They're sort of a regreening project with some Russian physicists, scientists, and some Brazilian meteorologists and climatologists, and got plenty of letters to their names, all very bright people.
Right. Yeah. Gorshkov and Marakeva are the Russian scientists, and the Brazilian, prominent Brazilian, Dobre, possibly. I'm sorry to interrupt.
Yeah,
I'm just
yes.
echoing that. Yes, these are names I've heard of.
Yeah. And it's all, I'm assuming they're quite intertwined with Michael Kravchuk's all his work and on the biotic pump there. And I just found it really fascinating learning about this week that they're talking about strategies of tree planting and that sort of stuff, and just saying people, if they're doing it in the right spot, like in China, they put these huge amounts of trees in. About 10% of it was successful because it was in the right spot. It was doing their biotic pump theory, drawing moisture in from the ocean. So it's not just what you're planting it all over the place. There probably is some benefit, but there's a lot more benefit with a strategic strategy of using these global weather patterns and biotic pump features and things.
Mm-hmm.
Yeah, it was very fascinating. Yeah, you other guys aware of that? I can hear that you are, Hart. Very interesting.
I'm familiar with the biotic pump theory. It's so Gorshkov and Marakeva, Judith Schwartz writes about them, and they have a paper that I've glanced over. But the biotic pump theory is the idea that forests make rain. And they do that in a few different ways. One is that they provide the water vapor that eventually becomes rain. Another is that they emit a bacteria called Aerobacter, and this bacteria is responsible for probably most of the rain that falls on land. The Aerobacter bacteria becomes a nucleus for rain. If you have rain, like a million water droplets, a million water molecules come together for one drop, and that doesn't happen by itself. It needs a nucleus. So the nuclei can be salts or ice crystals or bacteria. And the biotic pump is where your forest emits a lot of trees, probably most plants emit some kind of bacteria, and not very much is known about which trees emit the most, but probably trees emit more, and probably not all trees are equal in the amount of bacteria that they emit. But we know collectively trees emit the Aerobacter bacteria, which causes precipitation. A third way that forests cause rain is they create a low pressure, so moist air that is a cooler, lower pressure system, and it's either because of the temperature differential or because of the pressure differential that they tend to draw. They actually create winds. They play a kind of tug of war with the ocean, and they win the tug of war. And so this is the small water cycle. This is contrary, and this is contrary to, or this is a different angle on rain and water cycles from this, simplistic textbook. Here's the ocean where the water comes from, and it blows onto the land, and then it falls. Probably, if it happened that way, you would expect rain to only fall along coastal areas. But like in the eastern United States, the prevailing winds are from west to east. The west is dry and the east is wet. And it's not because the east is closer to the ocean. It's because the east is greener and is able to make its own rain. So what we need to do is to stop sabotaging this process. Tree planting can be okay. It can be fine, but it's a lot of time, a lot of effort, a lot of energy. We need to stop cutting down trees, and we need to respect the biome. If it's a grassland or a savanna, planting trees might not do much good, but we need to stop sabotaging what nature wants to do. And a lot of the trees would grow of their own accord if we would stop cutting them down.
So Judith Schwartz has a chapter in her latest book, Reindeer Chronicles, where she's visiting and interviewing Millan. That's Millan, repeated, who is a professor in Spain who has been studying for decades the effect of deforestation on the water cycles in Spain. And he says that because so many trees have been lost, southern Spain, and because it's so sunny, it basically warms up and creates a heat dome. And that heat dome, a high pressure system, keeps the moisture coming in off the Mediterranean. And so it's a positive feedback loop to the detriment of moisture in southern Spain. And so he's trying to convince people that they need to reforest in order to alter that and allow the water to come in. Michael Kravchak sort of amplifies this, and he says, part of what's going on. And of course, with climate, there's so many variables, it's hard to point your finger at any one thing. But he says this heat dome effect, the Pacific Northwest one we had, and other places in Europe, he says in the summertime, the land stays warm and keeps the water off. But in the fall, it starts to cool off, and then the supersaturated moisture comes in and creates these deluges, with increased, numbers of amount of rain that falls, and so you get this tremendous flooding. And he says it's all part of the yin and yang of this cycle.
Yeah. The one thing I love about this content is that it's common sense when you think about it. Not that all of it is common sense, but it makes sense when it's explained to you. And it like, Mian, you mentioned, interviewed by Judith Schwartz. He said, she asked him if the water cycles are so important, why don't we talk about them? Or why do we totally focus on carbon? He said, because you can talk about carbon dioxide for decades and not do anything about it. And that's exactly what we've done. We've talked about it for decades and we haven't done anything about it. And that there are certain elements that want it that way. And the elements that want it that way are the ones that want us to look the other way when they're raping the land. Not all of them understand this stuff either, but they know that we can get the public narrowly focused on carbon and narrowly focused on fossil fuels. And when you focus on carbon emissions, we're focusing on what's coming out of our tailpipe. And it's so much broader than what's coming out of our tailpipe. But the commercial interests have too much at stake. And like Judith has a hard time getting articles published in commercial publications because they can smell trouble. And trouble is anything that poses a threat to the sponsors and to the owners and the interlocking corporations that 4 of which own most of the commercial media.
So if I can slightly change the topic here, I left to come to this session. I left a session that was still going on, which was an environmental forum with the state of Maryland's gubernatorial candidates. And I was, wholly disappointed. In part, I expected to be, but everyone is talking about, net zero targets and solar and wind. And I think they're speaking to an audience that is not yet informed. I think, unfortunately, the physical reality of our situation is going to be the great teacher. But for example, most people don't understand because we've grown up for the last 150, 200 years in a system that was increasingly using fossil fuels to substitute for human and animal labor, and even somewhat for wind and water power of yore. But our economy now, our GNP is 98% correlated to the energy throughput in the system.
Right.
And about 80% of that in the US and most industrialized societies around the world, it's roughly the same, give or take a few percentage points. 80% of that is coal, oil, and natural gas. So if you're talking about getting to net zero by 2050, which is the popular slogan, you're talking about cutting out that 80% of your GNP. In Maryland, less than 1.5% of our energy comes from solar and wind. And that's after decades of building it. For the US in total, it's about 3.5%. So the ability to scale up those solar and wind devices as the fossil fuel energy declines, first it's going to be oil, then it's going to be coal, and then natural gas. And the fact that, you know, the paradox is that to build the wind and the solar, you need the fossil fuels to mine and manufacture the various components that go into those devices. There is yet nowhere in the world where solar and wind is built by solar and wind,
Right.
and it won't be.
Right.
So,
Look, if I can give my little stump speech on that, I think to me, solar and wind is an illusion. I mean, it's a series. It's a long string of promises that are not going to materialize into anything close. I mean, 100% renewable energy is a fantasy. I mean, let's talk about 50%. I mean, you know, how are you going to get there, for one thing? But, you know, so what we're doing is we're being seduced into a conversation where we change the way we generate energy, but we're not changing the amount of energy consumption. If you look at, let's look at three sectors: transportation, defense, and agriculture. You can look at those three sectors and no further, and you know, each one of them can reduce the energy needed by 75%. It's not hard. You can, on the back of an envelope, you can figure out how to reduce the energy consumed by transportation by 75% or by agriculture. And so to me, we need to radically reduce the energy consumption. And it's not about, you know, this is a step toward freedom for regular people. This is not like massive self-sacrifice on the part of regular people. This is wresting control of these sectors from the few people that profit. That the transportation sector is not designed for transportation. It's designed for profit. It's designed to extract money to the tune of $8,000 in America. $8,000 a year per car is what it takes to own and operate a car. And that would not be necessary if we had, you know, mass transit and multimodal transportation. Agriculture, there's a whole heck of a lot of fossil fuels that are used because it takes 10 calories of fossil fuels to create 1 calorie of food, because natural gas is used to do these nitrogen fertilizers. And that's just one element of what causes the consumption of fossil fuels in the agriculture sector. It's not complicated engineering. It is who's making these decisions. And it's not us. And it's not the 99%. It's a 1/10% who are making the decisions and designing these entire sectors of our economy for their own benefit. And we haven't even talked about defense yet. It's you know, defense doesn't make us safer. National security is that almost none of our defense has to do with actual national security. National security is not actual security of the people. Well-being and security of the people is not a priority for the people that get to make all the decisions as to what we're going to have in terms of weapons and weapon systems, et cetera, and all the propaganda, et cetera. So I say the renewable energy conversation, the 100% renewable energy conversation, is a complete distraction and diversion from what really needs to happen, which is, you know, yes, a low carbon world, but, you know, anyway, I could go on. But I mean, it's like, who's this Hart Hagen guy raving like a lunatic? But that's how I see it.
So Lucy, how are things in Bar Harbor?
Well, finally quiet. I think everybody decided to come here because they thought it was safe. We had so many people in Maine. It was I mean, if you're a local, everybody just is praying for snow. But we'll go home. No, it's just the way. You have to understand Mainers. But anyway, otherwise, it's really quite lovely. I've just spent most of a good part of my summer in my garden. So I'm trying to get.
What are you
Well,
growing in your garden, Lucy?
what am I growing in my garden?
Yeah.
Oh my goodness. Well, I have in the front yard. I have some interesting plants. One is called it's Regosia. It looks kind of like a rhubarb plant, but it's not edible. So it has these giant. You would love it because so what I've been really trying to do is get as many perennial plants going
Right.
as I possibly can. And then I've grown beans and cabbages and tomatillos and lettuce, and so anyway, I'd like to get a whole permaculture site. Is really sort of what I'm going for. So
all that's very
it's a big
important.
blueberry state. Maine
Yeah.
is
Right.
big blueberry state. So I have almost an acre, even though I don't have that big. The house is small, but I've got a lot of land. So I've just been slowly putting it all together. And then in the last couple of years, I've had, just because of what I've planted, I've had monarchs coming daily. When they've left now, obviously, but anyway.
So you told me last time that you have milkweed and coneflowers and asters and one other thing that I forgot.
Yeah. Coreopsis. Milkweed, yeah. Oh, Joe Pye weed.
Great.
Yeah. But they come. You just put them in. It
Right.
doesn't. It's not really rocket science. You put them in, and the monarchs come.
Yeah.
Yeah. So it's fun that way. No, it's been a beautiful season. More rain, a little bit. Last year was really dry. This year we've had a lot of rain, but I don't mind because we've had. Bar Harbor in 1947, there was a big fire here, and nobody's ever forgotten it. So if we go through a summer and we don't have much rain, everybody starts worrying we're going to have a repeat of the fire of 1947. It's been a good season, good but very busy season. Everybody's been dying to get out of their house, so they think they drove to Maine.
So let's talk about all the benefits of having your own garden for food and otherwise. We're doing that. Even if you grow a little bit of food, you're circumventing the industrial food system. We're creating green spaces. We're creating habitat for wildlife. We're doing good things for the water cycles. We're doing good things for the carbon content of our soils. We're building healthy soils. Just for starters, a little bit of sense of community and neighborhood. All that's very important and very helpful.
I'm getting ready to put in my garlic. That was the other thing.
Right. Did you save your cloves from last year?
Well, I have a lot. I still have a fair amount of garlic. I tend just to, I guess it's just habit. I go to the local sort of organic gardening center and I get seed garlic.
Okay.
Yeah.
Well, thank you, Hart, for doing this.
Thank you.
Interesting evening, letting me yap on a little bit about various aspects of it.
I would have been disappointed if you hadn't yapped on. It's like, here's Philip. Why is he not yapping on? What's up with that?
And David and Steve and Marin and Alpha, you came in late, but welcome.
Hi.
Well, Philip's going to sign off. Y'all can stick around if you want. Hi, Marin.
Good evening.
Bye, Philip. Thank you.
I'm moving around while I listen.
So, Marin, what's new?
Oh, I'm finally getting going on some building projects. And it's turning cold. So at the moment, while I'm moving around, I've been clearing off a really big table and I need to figure out how to protect it. And put my plants on it because the building project is where the plants would normally go. So that's my current challenge. So I'm
Mhm.
spreading out this leaf table and going to try to figure out ways to protect it.
Mhm.
Over the next, probably take in the most tender and most precious plants tonight, and then
Mhm.
tomorrow night it's supposed to go down to about freezing. And we live down in a valley, so tomorrow all gotta come in. So, so yeah, your presentation ran the gamut from pretty basic stuff to pretty esoteric stuff.
Mhm.
So hopefully folks took away food for thought. I'd like to try to get my spouse, who's a climate scientist, among other things, to this, I think was the, again, I was in and out while I was moving around, but I think this was the most, perhaps the most compact version toward the end, on your thoughts on water versus fossil. I didn't hear it all. My one basic thought is that unless keeping water in the soil is keeping it out of the atmosphere, which it's a great thing to do for all kinds of reasons in terms of resilience, it's not going to reduce the amount of water. I think there's so much water. Water is the most important greenhouse gas, and there's so much water, and there's like oceans. So unless capturing more water in the soil is taking it out of the atmosphere in some big way, I don't know that that you can say that. But again, I didn't hear it all, so I need to reconsider that.
Well, I think there are multiple benefits to having water in the soil.
Oh, definitely,
So,
totally.
yeah, right.
I mean, I've taught people in Saudi Arabia about desert permaculture
Hmm.
because they were so clueless. And
One interesting angle on that is that, you know, the amount of, like, the ocean levels rising is an issue, and the mainstream climate conversation points to they make it seem like the ocean level is strictly a function of melting ice caps and melting glaciers.
there's two main things. One is the melting caps, melting land ice, not melting sea ice. So not ice caps in general. The Arctic polar cap melting does not affect sea level, just as you melt an ice cube in a thing of water and it's still there. But I mean, the water level doesn't rise, but it's land ice, it's Greenland and Antarctica that is key there. But also water swells up, it's bigger. So water
so it's the heat effect, it's the expansion, due to heat. Okay, so all of that, I hear all of that, and what's missing is the amount, like Michael Kravchuk talks about, he can quantify the amount of fresh water that is no longer on. There's a certain amount of fresh water each year that leaves the continents and goes into the oceans, never to return on a net basis.
Never to return. What about there's more evaporation from the warmer oceans?
Okay.
So I don't believe the never to return. Sit down, now that I'm part of the conversation. Sit down and participate.
Yeah.
So, and again, I didn't hear all your arguments, and I do want.
Well, just because it evaporates doesn't mean it comes back down as rain. And even if it comes back down as rain, it doesn't mean it is held on the continents as fresh water. We need to, for a lot of reasons,
and
we need to
more
increase,
soil, more better soil.
Let me finish. For a lot of reasons, we need to increase the amount of fresh water on the continents. You know, we could name 7 or 8 reasons why it's beneficial to do that. Including
there's all
the cooling effect, the ability,
what?
The cooling effect, the extending green growth, nurturing ecosystems, reversing desertification.
Totally with you there.
Yeah.
The net return, there's certainly the question of whether you're recharging aquifers versus just all running off into rivers and ocean. So the speed of return, but it's like, if you build a dam and make a reservoir, assuming that the same amount of rain is falling in the mountains, then you are stalling it on its way. So there will be a temporary decrease in the amount of water downriver. But after the reservoir fills to whatever level it lets it out over the weir, then
Marion, I'm
be-
concerned. I'm sorry to interrupt. I'm concerned about our listeners and the background noise.
My spouse is cooking supper.
Okay.
The aforementioned planet scientist.
Yeah.
So I can let other people talk and just go back to listen mode. But I'm in
When
this-
when I think of dams and reservoirs, here's what I think. For one thing, that usually does little or nothing for the water cycles. It does little or nothing for the groundwater. Usually the reservoirs are for irrigation. That irrigation water is pumped into whatever crop it is, and it runs off or it evaporates. And so that's one thing. And I guess there's a couple of things there. And I feel that if we want to make the most of dams, we're going to build small dams up in the catchment rather than large dams down in the catchment. Plus, these large dams are we've got to stop relying on fossil water, and we're doing the wrong kind of irrigation. And farming needs to radically change. And so
I'm not suggesting that dams are the right thing to do. I'm
Yeah,
using
right.
as an analogy to soil slowing the return of water
yeah,
to the oceans.
well, I think that
But now I kind of have to go. So
okay, Mary, I didn't mean to be rude about the background noise, but thank you for
Yeah.
coming and talking with us.
that's why I was muted the whole
Yeah,
time.
right. All right. Have a great
Anyway,
night. Let's talk soon.
Yeah. All right. Well, thanks.
Okay.
Interesting. And I presume it's there on Facebook if you streamed it.
Yeah, it'll be on Facebook and YouTube.
Okay, great. All right. Thanks a lot. Have a good
Thank
night.
you. Bye-bye.
Good to see you again. And thanks again for coming to the Sustainability Salon.
Oh, my pleasure. Anytime. I have to miss this week, but in subsequent ones, I should be able to attend. All right. Bye. David and Steve, looks like it's just us. I have the Joe Rogan theory of podcasts. It's like, keep going. And if people don't want to watch, they don't have to. But, I'm not going to artificially limit the length of these things. We've got important things to talk about, so. Steve, tell us again about your system of, don't tell me it has to, it's a pump that is electricity free, and it works on gravity fed systems. So you're catching water in ponds and you're feeding the water into a swale downhill, and that helps your water tables and other stuff.
Yeah, yep, that's right. And when everyone talks about all these different water runoff issues and carbon, soil, alarm bell goes, oh, I think this idea, maximum infiltration is the name that I've given it.
Yeah.
I'm a permaculturalist and a gardener and a handyman, so a machine operator. So I think being a permaculturalist and being aware of the regen ag space, you're really aware of the improvement that can happen in a hurry when you get that soil structure happening. So it's quite different to a geologist or a hydrologist or something like that, that with their dealing with sort of basic parent materials. You know, when you're listening to Walter Yanni and others, they're talking about voids of 60% and things like that, where when you're doing your basic infiltration tests, it's just like pouring water in a hole. You know, it's seconds to put large amounts of water in.
Right.
So yeah, the appeal for me of my maximum infiltration idea is that you can supply that water when necessary, because you need moisture to keep soil biology going, otherwise it just goes dormant and shuts down. So yeah, I don't know if Dave has seen anything of it, but I've posted off on the Water and Climate Facebook page. And yeah, and I'd love to have a chat with you one day, Hart, about it. And you know, if people have questions, they can ask the questions. And it's sort of an evolving idea in my head. So the more I explain it, the more
By all
I
means,
refine how I'm describing it.
we can set up a call sometime, especially for that.
Cool.
Steve, can I just ask you a few questions? Whereabouts are you based, and your system, is it sort of like a modification of either keyline or natural sequence farming?
The same principles. It's in distribution of water and slowing it down, but it's quite different in function. So I think that the way that I'm most recently describing it is that it's so sort of you've got the swale on contour, and then you've got a mid-slope dam, and you're releasing it down to a lower swale through a bunyip pump, and that water's coming out over a long period of time. So different in keyline and natural sequence farming in that way. I think I describe it now as you're increasing infiltration time by a multiple of hundreds or even thousands. So that's where the benefit is. So that a very slow infiltration rate of a couple of mil per hour in a heavy clay soil like I've got, I can infiltrate a whole wet season because I'm doing it for months on end, and I'm turning it on periodically, turning it on and off to get the desired moisture. So it's quite different to natural sequence farming and keyline.
Let me ask you a question about that, Steve. When I think of keyline or masterline system, masterline is what Mark Shepard calls his version of P.A. Yeoman's keyline system. And when I think of either one of those, I think of either swales or plow ditches being, you know, maybe 3 feet apart. Whereas, you know, your swales are probably much further apart, right? And so it would seem to me that the advantage of your system is that there is less upfront design. I mean, if you build a few ponds and you have your pipes and pumps supplying water to a couple of swales, and that there, it seems to me it's less tricky at the design stage. Is there any truth to
that? Potentially. Like I don't see any reason why you can't use keyline plowing or setting up within the system, because you've got that gravity irrigation. That's another part as well, Dave, that the bunyip pump has got fairly good capabilities as a fuelless pump to get a percentage of water uphill, a smaller percentage, and then the majority is exhaust water into the lower swale. Different workplace platforms are really sophisticated at working out the return on investment. And,
Steve, I'm trying to be conscious of the
dollars per.
Steve, I'm trying to be conscious of the audio quality. Your sound is cutting out a lot, and I'm afraid I don't want to run people off because of that.
Sure. Yep.
So
is that any better? Yep. I'll go and jump in the car, and hopefully that'll be better.
It might be. It might be.
Steve, I've sent you a friend request, and I'm keen to hear more about what you've got to say. And Hart, it seems like you are fully up with what Steve's talking about as well.
I know a thing or two about it. He described it to me last week, and hope to be learning more about it. It's a fascinating system, you know.
Yeah, I think I'm assuming that once people understand the idea, they'll do exciting things beyond what I've thought of so far. So that the basic idea is you're releasing water over a long period of time.
Exactly. Instead of having to wait for a rainfall. I mean,
That's right, yeah.
when I think of a keyline system or a good system of swales, or even, you know, when you have high soil quality, you know, these systems can absorb nearly all the rainfall, but that's a whole, so that's something that you get to over a period of time. Especially soil quality, it takes a period of years to develop the soil quality. But you're talking about a system where, you know, I mean, you can just drip that water into the swale, you know, for very gradually in between rain events, or however long you have. And it would seem to be like really helpful, well, in an area with long dry periods like 7 months or whatever.
Yeah, and it gets it out of evaporation. As we were saying last week, water sitting in a dam evaporates. If you can get it in the ground down to living roots, you're changing your small water cycle, and then you're getting that low pressure, moist, cooling area, and then you can bring more moisture and less extreme events.
Right. So that drip is going to extend your period of green growth. And then when you have green growth over the course of time, especially if it's a diverse ecosystem that nurtures like soil fungi and soil carbon, then over the course of time, you're going to have something. So that's kind of like the ripple effect. You know, you supply water, your plants can grow, your roots can grow, and then it's a virtuous cycle. It is then able to absorb more water on a rain event.
Yeah, that's right. I think some of the places that excite me are some of the rangelands where you need a certain topography for it. And if they're able to pump up to a higher water reservoir, whereas previously it wouldn't have made sense because of the money costs to do that sort of thing. But if you can have that gravity feed down to a rangelands area and have that ability to water your pasture after some planned grazing goes through, already planned grazing is, you know, working at like 4 times the carrying capacity of other operations. Like if you've got that ability to irrigate afterwards in a dry area where you're having like resting periods of a couple of years, that's a big multiplier effect and beneficial for the whole environment.
So how does that fit into the resting period? Like your resting period of a couple of years is the time that you've chosen according to holistic management. So there needs to be a period of rest. And I'm accustomed to think that maybe sometimes it's 3 months, 6 months, maybe a year, but you're talking about you're talking about 2 years in between grazing periods. Is that correct?
I'm talking the most extreme, the desert areas of where I hear about Mexico and down in the south of the US, where it's there's very little vegetation, and they're bringing animals in to stimulate to get things going where there's very little. So yeah, resting periods, from my understanding, vary from probably as little as a couple of weeks when you've got the right season, up to a couple of years. If you've got the irrigation capacity, I don't know what that multiplication effect would be, but you'd assume it would be a lot. And because you're able to do it on a large scale, you're changing your actual environment, which is the exciting feature for me, and what some others people have jumped on as well, which they're saying, you know, we can affect our small water cycle in a big way. The swales can run for as long as you want. If you've got a catchment where you can run it for kilometers, you can do that.
Yeah, I've read Holistic Management by Alan Savory, but I didn't fully absorb what he was talking about in terms of how you choose the the paddock, like where your animals are in at any given point in time. He made it sound like, it's not, rotational grazing is not the right concept. It's more like, you choose a paddock and then, there's a method to it that he made it sound like a grade school kid could do it. I just didn't quite pick up on it. Like there's this chart and here's a month, here's a paddock and here's a month or a time period, maybe a week or a day. It would seem that some of it is a result of just eyeballing and intuition and not just, maybe you can't predict months in advance where you want your animals to be.
Mm-hmm.
But
Yeah. I haven't read the book, but I've listened to many of his lectures and other people speaking on it. I think one point that they would emphasize and that you'd know of, that it's a whole range of factors from your economic to your social to your financial, environmental, and that's all part of the planning.
right.
And in part of that environment factor, there'd be certain areas that you don't want them to be when they're wet. Other times there'd be certain points that you want them to be close. If they're getting shipped off, you want them to be at a certain point.
Right. And you kind of want to, you want to go from, you want to, you don't want them to have to travel too far when they're being rotated. You want to go from adjacent to adjacent to adjacent. And then, like you said, end up, if they're going to be shipped off to processing, then, you want them to end up at a place that's fairly convenient.
Yeah, that's right. Yep. Yeah.
I know that I'm in Kentucky, which is similar to where Joel Salatin is in Virginia. And he says that, like cow days per acre per year is the measure. And he can get 400 cow days per acre per year, whereas the county average is 80 cow days per acre per year. So he quintuples the county average by rotating using electric fences. And he says his 10-year-old, when his son was 10 years old, he could do the electric fence thing and the cows are conditioned for it. And then when you do that, they're eating much taller grass. The grass is just ready to be chomped on because it's much taller than it was before. And then when you do that, you can shorten the period of time per year that you need to feed hay. So
absolutely.
Gabe Brown in North Dakota, says he feeds hay for less than Texas farmer. North Dakota is the far north, Texas is the far south, and he feeds hay for less per year, less months per year, less weeks or months per year than farmers in Texas. So that's because of that's number of factors, but it's holistic management, it's rotational grazing, it's having good soil, it's having diverse crops, it's grazing your cattle some on your croplands, and other factors.
I think.
I'm
Sorry, you
gonna
go,
go, guys. I've really enjoyed everything, and I'd like to keep in touch with both of you. But I'm going to have to go.
Sounds good. Thank you for joining us, David.
Thanks, Dave.
Thank you.
Yeah, I think Hart. I think Gabe Brown's got one of the ultimate setups with his large-scale cropping and cattle. I think it's one of the ones to emulate, I think.
Yeah, he Dirt to Soil is just one darn good book. And I'm sure he has other resources. I know he has YouTube videos. I'm sure he has courses, and he's part of this nonprofit thing that educates farmers. And I'm sure he has a lot of resources that I have not tapped into yet. But he's a really good educator. He loves teaching and does a real good job of it. Plus, for decades, they've just had top-notch scientists to come in and analyze what's going on, scientists from the USDA, scientists from other agricultural institutions, or agricultural universities and the like. Plus, he's had some people from Australia to come in, like Christine Jones has been to his farm and has analyzed it. And so it's top-notch people able to document what's happening and why, and providing the scientific data that's so important in some circles.
Yep.
Some circles.
Well, that's right. Yeah, that's the point that some of these climate people were saying. Peer-reviewed papers are good. Or Alan Savory makes this point too. You can't wait around for that. We really need to share the anecdotal evidence,
right.
And
well, I was thinking about this today, and I think I wrote a meme on it. But I'm a math major, and I was passed 2 actuary exams, and I was a tax lawyer, and I'm not afraid of numbers. But sometimes numbers. Are numbers used to clarify, or are they used to obfuscate? Are they used, so, I think sometimes numbers can obscure the important issues. It's like Mark Twain said, there's lies, damned lies, and statistics. There's liars, there's damned liars, and then there's statisticians. Just because you attach numbers to something does not mean that you're thinking clearly. And we need to not be intimidated by people that say, oh, where's your peer-reviewed research? That has its limitations and its pitfalls, and it shouldn't, like you said, it's not a substitute for common sense. I'm not going to get a peer-reviewed paper to prove that the sky is blue, and so that's all I have to say about that.
Yep.
Well, Steve, I think this is a good place to end. We'll talk soon, and we'll set up something. Maybe next week or the week after, something like that. I'm not trying to put you off. I'm going out of town this weekend, and we'll talk again soon. And I'll look over what you sent me, and you have a really good system, and it needs to be compared and contrasted with other methods of harvesting rainwater and building soil health and that kind of thing.
Yeah, or combined, or whatever combination.
Yeah, combined, right. Yeah,
I've probably got a little bit to work on it. I want to fix up a little bit of the modeling. So yeah, I'd love to have a chat one day, and probably, I think, putting the concept out there, and then people can have a little think about it for a little bit, and then they can come in with their questions. We'll probably have better quality questions. And it might even be able to have so pre-answer some questions.
Yeah, sounds good. All right.
Awesome.
Thank you.
Thanks,
have a good night. Have a good day.
Thank you. You too.
All right. Bye-bye.